Welcome to this talk with the title of the power of visualizing constraint in software architecture. Okay, it's a bit long title, but you will see the topic will be quite interesting in my opinion. So let's start introducing myself. I'm Francesco Strazzullo, and I'm the Chief Operating Officer of Clarinet Italy. There is what is a service integrator in Italy. I don't like to talk about myself too much, so I will just tell you that you can find me on LinkedIn. I have a newsletter on Substack, and I'm also a mentor on Mentor Quiz. So feel free to connect with me after the talk, in whatever way which you prefer. So let me start this talk with a little story. This is quite funny because at the same time, there is a talk about, if I remember correctly, building a game engine, retro game engine. So I don't know why you're here. In your place, I would like to listen to the retro game engine. But apart from that, this talk, I started to think about this topic, and then in this talk, 10 years ago. Because 10 years ago, I was at one conference in Germany about JavaScript, and I had to talk about, I don't remember, probably the new JavaScript framework of 10 years ago. Before me, there was another guy with a talk presented by a dumb NAS. It does not have the slides. It does have a NAS connected with HDMI, and the slides were an actual card that he put inside the NAS. So I was freaking out because I said, okay, it's impossible for me to let them listen to me after a guy with a dumb NAS as a slide presenter. But apart from that, the talk was very interesting because he talked about a framework to build NAS games in JavaScript. Don't ask me why. I don't know why he built something like that. But the interesting part of the talk, and this is why it's connected to this one, is that he talked about constraints. Because when you work with actual hardware, very, very old hardware, you need to think outside the box to fit the constraint of the system. Okay, Super Mario, for example, has a mustache because they don't have enough pixels to make the smile. And it was how they created probably the most popular character in the world, apart from Mickey Mouse, because of constraints. This stuff I started thinking, I was very, very young at 10 years ago, and I started thinking about this stuff, and I started thinking about how coding exists only in context. What I mean is that you really become a senior developer when you understand that your code is just a means to reach some other goal. Usually to make some other people make money, or to make yourself make money if it's your product. But coding by itself, software architecture by itself, does not exist in laboratory. Exists only in real life, so only in context. Okay, so let's try to go deeper on this topic. So what is context? Well, while it's quite easy to understand, it's quite difficult to explain it with words. And it's quite difficult to explain how to, define context in software architecture. While it's probably a simple concept to understand, but it's a difficult concept to express. So let's start with the definition of context of the Cambridge Dictionary. Okay, you can take whatever dictionary you want. We have three definitions, okay, three main definitions of context. The first one is the situation within which something exists or happens, and that can help explain it. Okay. The text or the speech that comes immediately before and after a particular phrase or piece of text that helps to explain its meaning. Okay, not so good. And the last one, the influence and events related to a particular event or situation. None of the three definitions that I found in the dictionary can actually help me explain what context means in software architecture and what are the consequences on different concepts and different contexts in software architecture. So let's try a completely different approach. Let's ditch completely the definition, dictionary, words. Let's try with a simpler approach. Let's play a game. Now, let's imagine that you need to build a product, a software product of any kind. It could be a calendar app, a to-do app, your choice. The product does not matter in this discussion. Now, imagine that you need to build the product 2 times. The first time is for the mega corporate with 10,000 employees based, I don't know, in some very huge skyscraper in New York or something like that, a bank, whatever you want. And the other product, exactly the same product from a functional point of view, is from a startup built in a garage in your neighborhood. Okay, these are 2 extremes, okay? I'm talking about the same product, but in 2 extreme different conditions. What happens that the product will be quite different. I'm not talking about user experience. I'm not talking about the final product. I'm talking about the actual code and the actual software architecture beneath it. And you know why this happens? Because probably the startup, you know that you have 90% probability that your company will fail. This is actually what happens with startup. And so, your first objective is time to market usually. Your first objective is to see if your company, or the company that you work for, if you're an employee, will survive the next 6 months. On the corporate side, you will probably need to fill a lot of documents and paper before even start writing the first line of code. You will probably start 6 months after what you believed just because you need some kind of approval from somebody else. Okay. Of course, I'm exaggerating, but just to let you understand that, as I explained before, I didn't talk about the product. I just talked about the situation in which this product has been built. And we will have 2 completely different products in the end. This is because when developers tend to think about what they need to do in the day-by-day job, they usually think about what the software should do. And we know that because we know all the drill. We have our backlog that is defined by user stories in many forms, like as a logged user, I want to change my default setting because I don't know, that kind of stuff. This is what the software should do. But the point is that we need to concentrate, or at least there is a lot of information in how the software should be, not in what the software do. And remember the example that I made before. I didn't talk to you about what software do. The software that we need to build for the corporate of the startup was completely unimportant in the discussion. And so the way that, from an engineering point of view, we could define context or constraints, if you want. From an engineering point of view, it's called non-functional requirements. It's also called in English, they are also called entities, because as you can see, this is a non-comprehensive list that you can find on Wikipedia. The most of these words ends with entity: maintainability, platform compatibility, usability, readability, etc. So they are called entities in a less formal way of non-functional requirements. So this is a way to distill the characteristic of a product. So as you can imagine, different business with the same product could focus on completely different non-functional requirements. And these functional requirements could drastically change your software architecture. You may have, for example, some, oh, let's find an example. Okay, an example. This is a true example that we made with a client. Um, Everybody knows that it's almost impossible to have a zero bug software, okay? Because shit happens, okay? That's the common, we know it, we can do probably anything about it. So something will happen. So what is how can you approach, for example, the robustness of your code base? What I mean is the single bug in which you will, that you will put in your code base, how much can impact your business. It really depends on the kind of business. I can make you an example. My grandmother has almost 90 years, but for some strange reason, she is able to use WhatsApp. Okay, don't ask me why. I never saw her never use anything more complex than a TV remote, but for some reason, she has a tablet and she can use WhatsApp. What happens when WhatsApp is down? Shit happens, okay. And sometimes it happens. WhatsApp sometimes is down. When WhatsApp is down, my grandmother calls my mother, and she calls me, because she thinks that the tablet is broken. Because she has 90 years, okay, so be kind with my grandmother. So she doesn't understand what the meaning of bug, of the meaning of downtime. Because for her, electric stuff or work or it doesn't work. And this is probably an hardware problem, an electricity problem. On the other hand, I have probably a teenager. Actually, is probably, they understand what downtime is or what bug is, because they work with Fortnite, and sometimes Fortnite does not work. Shit happens, but they know that. So, for example, if you target persona, target user are teenagers, you probably could, and you are a startup, probably you could care less about downtime. But if you are creating, for example, a non-banking app for elderly people, you cannot have a downtime never. Because the first time that you have a downtime, they will get all the money and put them back under the bed, like they did before. This is what I mean. The same bug, different context, completely different consequences. Now, as I said before, this is I just taking extremes just to stress my point that this stuff, it's very, very important to understand, and it's very, very dependent on the context of your business, also with the same code base. So, in a nutshell, apart from the stupid example that I made, we can safely say that context is a subset of non-functional requirement valid for our business. So every business, every company, or every company in different time of the year of the lifespan of the company itself should have a subset of non-functional requirement in which they need to invest time and resources. Now that we understand that context, that is what should drive our architectural decision, and is a bunch of non-functional requirements, we need to define three important things. The first one is how we choose this non-functional requirement. Because you cannot have everything, okay? You cannot have an architecture that solves all the problems in the world that is performant, cost-effective, I don't know, bug-free, and whatsoever. You need to focus only on some stuff, because as you understand, you are developers. You know that if you want something, probably you need to compromise something else. That's a point of engineering, and that's the point of software engineering itself. You cannot have everything. You cannot have a software built in time that costs nothing, and so on. This is common knowledge for developers. So the first thing is, okay, let's decide all together in which non-functional requirement we need to invest time. The other, we don't need to discuss them. An example of why it's important to choose non-functional requirement and why it's important to let everybody in the team knows. Right now I am a full-time manager, okay? I manage team of engineers all the time. But my background is of a front-end engineer, okay? I work as a consultant in front-end engineering for 10 years. And some years ago, I helped the team in choosing their next front-end framework, okay? It was the time it was very, very messy because there were a lot of JavaScript framework out there, okay? That was that kind of market at the time. And they had a very old application in jQuery. And they wanted to port it to, I don't remember, Angular, React, Vue, okay, that kind of new frameworks. And they had 2 days of discussion before talking to me about performances of the front-end application. And they were talking about how to gain 15 milliseconds of rendering performance instead of jQuery. So the point is what they were talking about a complete porting of the application, and all the discussion was about gaining 15 milliseconds of rendering. That is important, okay? I'm not saying it's not important. But then I tried with them the real production application, and every network request was like 1 second. I said, why every network request is 1 second? In the network tab of Chrome, okay? You see start, 1 second, end, just to get 3 rows from a database. And they said, oh yeah, we have a very, very big problem with database optimization. That was the point. I said, stop it. You don't need to change your fucking JavaScript framework. You need to solve this problem. You cannot talk about gaining 15 milliseconds of rendering if every query on your database took 1 second. And then their software was quite a very important software in Italy about, how can I explain it? It's like the Italian version of Alfresco for Italian bureaucracy, okay? So they store documents, okay? That was the point. And they sold this software starting in the 90s. So at more of 30 years of software going on. So there is a lot of legacy, a lot of dust under the, hidden. So it was a mess, okay? But I asked the customer support of the client if anybody in 30 years ever complained about performances. Nobody complained about performances. And that's why it's important to choose a non-functional requirement, because if you don't do that, if you don't tell all your team that these 5 or 4 points is the key points where we need to focus our architecture, they will probably talk about unimportant stuff. Because their team they were 5 front-end engineers, they were talking about optimizing performances of something that was not related to them at all. Then you need to communicate them. Okay, you choose your non-functional requirement, you find a way to define your context. You need to be sure, remember the performance problem from before, that your team knows them very well, knows what you mean with non-functional requirements. At last, you need to help the team in implementing them, and be sure that their solutions goes in accord with your non-functional requirement. So the title of the talk was about visualizing, because all the tools that you will see are tools that should help your team in making your discussion as much as visual as possible. The point is that you could write a 20-page paper of this where describing how your application should work, the kind of slide, the kind of context, non-functional requirement that you need. But the truth is, a picture is worth 1,000 words. So probably what I study in these years, what I do when I need to help a team to define the context of the software, I try to use as much as possible visual tool in order to help them remember not just the outcome, but also the discussion that lead to the outcome. Something that documents usually don't do. So let's try with a first very, very stupid, naive almost, exercise that can help shape the discussion that lead to choosing non-functional requirement. This tool is called trade-off slider, and it's simple as just make your stakeholders order these 4 items. You may say, okay, how much? It could be very stupid, 10 seconds in order to sort 4 items. Okay, let's try to do that with 2 founders of a startup, with the CEO and the CTO. Try. It's quite funny. They will never get around the same idea of budget, quality, scope, and deadline. Okay? But now imagine that you need to build a product, okay? And don't think about corporate startup, okay? Let's just focus on this one. And sorry. And imagine that you need to build the software. You know exactly what the software should do. So you have a bunch of user story to implement, and you need to start in from scratch, from a greenfield approach. And then you have these items ordered exactly in this way. Budget is the top priority. It means that we can't spend more than the budget we allocated. If we do that, we fail. There is no way to get more budget. Then we have the quality, then we have the scope, and we have the deadline. So this chart tells us that in order to have a quality product on budget, we can reshape the scope and we can change the deadline if needed. Easy enough. Now imagine that you need to build the same product, but switch completely the order. Okay? So deadline on top, scope on second, quality on third, and budget on the last one. It means that in order to build exactly what we need on scope, on time, because we have, to present this stuff to some investor or we'll fail, we can spend more money than we need and we can ditch the quality completely. Imagine that you build the same tool, but just switching these items can tell you a lot about how you need to work. And this stuff, printed on a wall in an office or kept in a Slack channel if you are remotely, can help all the team remember what they are doing. Every decision that they made, from the top level architecture to the daily task that they need, should match with these 4 items. Because if you do this stuff wrong, you will probably mess up with the deadline, budget, or whatever. Another interesting visual tool that help shape what is happening around our business or around our software is called the SWOT analysis. The SWOT analysis is the acronym of strengths, weaknesses, opportunities, and threats. And this is a way to analyze a business from the external and the internal point of view. And we talk about our strengths, the strengths of our company, the strengths of our product, the strengths of our team, the strengths of our market. Then we talk about the weakness of our product, our market, and so on. This is our internal analysis. And then you have the external origin. So you have the opportunities that you have in the market, the opportunities that you have outside, the opportunities that you could have in the local community. Or you can have the threats of your market, community, or whatsoever. This is, of course, this is a very complex tool to use, okay? There are books that just talk about SWOT analysis, okay? So I will not explain you how can you use this stuff in order to shape your business, okay? But the point is that also just visualizing the stuff around you in these 4 diagrams can help you understand the hidden truth about your software. For example, if in the opportunities you have greenfield market, so you have an idea, a new idea that nobody has around you. What is telling you about, for example, this chart? Imagine that in the opportunities you have new market. We have a new idea, there's nobody there that have the same idea, so we don't have competitors. What tells you? That probably your time to market should be as short as possible, because you don't know if there is in here there will be anybody that have the same idea. On the contrary, if your threat is a full market, so for example you want to create a new messaging app, okay? The market is full, and you have very let me say low probability to have more such as WhatsApp or Telegram or Signal or whatever. In that case, probably you don't have the problem of the deadline, because in here you will be probably in the same situation. You have the problem of quality, and you have the problem of budget, because probably you need a lot of budget to create a messaging app that can compete with WhatsApp, for example. Okay. So, as I say to you, this is a very complex tool, so it's something that you are interested in, you should deepen the knowledge of this stuff. But it's just an example of how just visualizing stuff can help you shape your software product in a very deep way. Okay, so now let's not talk about tool, let's talk about how can we involve people in the discussion. Because as you understood probably, this is a business discussion. It's not directly a technical one. So you need to put on the same table tech people and business people. And trust me, I did quite often this stuff. It's not easy. And it's not easy because tech people tend to talk about tech stuff, but they don't talk about money. Business people talk about money, but they don't know anything about the consequences of their decision from a technical point of view. So a way to help in this kind of discussion in order to distill non-functional requirement is called the fishbowl. The fishbowl is the bowl where you put the red fish. Okay. By the way, I discovered that in Italy you cannot build the fishbowl because it's bad for the fish. Because my son wanted the fishbowl because it saw it in a cartoon. I go to a pet shop and say, no, you need to build an aquarium, but we don't have the space, so it was quite a messy day. But apart from that, the fishbowl works in this way. Imagine that you have 20 people that need to discuss something. They make a decision. You put 5 people in the inner circle of chairs. Or you can do, of course, you can do that with Zoom, Slack, whatever, okay? But with chairs, it's easier to understand. And you put the other 15 chairs around the 5 one. So you create an inner circle and outer circle. And then you have a topic, of course, and you have 15-minute time box. And you start the discussion. The rule is that only the people inside the circle could talk. The people outside the inner circle could not talk at all. They could just take in notes. After 15 minutes, people outside can make questions to the people inside. And after the question and answer moment, a person from the inner circle should go outside, and a person from the external circle should go inside. And then you start again with another time box until the time is over or the topic is solved. Why this is a very interesting trick for meetings? because you can involve the people, but you can pilot the conversation in a direction that you need. For example, you can start with board members in the inner circle, and they need to define the strategy of the next year of development. Okay, they are not technicians. They are talking about money. They're talking about revenues. After that, one of the board members exit, and you put them a tech leader or somebody that can continue the conversation when they left and start talking about technical stuff. After 1 hour, all the board members should be outside, 1 hour and 50 minutes because they are 5, okay? And you have all technical guys on board. But the discussion after an hour is already on the plate. So you have the board that had guided the discussion to a point, and then you have the technical people that actually try to implement the solution. This is a good way, in my experience, to have a constructive discussion about this topic. But this is just one way to do that, okay? So let's imagine that now you choose with dot voting or whatever you want, 5, 6, 5, 4 non-functional requirements. Usually I try to keep them around 5. Because the more non-functional requirements you put on the table, the more complex the discussion will be. Okay? Okay, we choose the non-functional requirement. We use some visual tool like the trade-off slider, the SWOT analysis. Okay, good job. So we know that our software should be affordable, credible, usable, effective, and reproducible. Okay, don't ask me what reproducibility means in this slide, okay? But I found it on Wikipedia and I posted it here. Like you can read the meaning of Wikipedia. And of course I'm joking, but an important step that you need to make when you choose the 5 words is to be sure that everybody in the room means the same stuff. So what I propose is that after you choose the words, write a small dictionary of what you mean. What you mean with the I cannot tell, I can even spell it, okay? Write it down in a document this time, okay? It's not visual, but it's okay. It's just 5 words with a simple definition. But be sure that everybody in the room knows the definition at heart. Okay, it's time to communicate them. So let's make a simple chart for now. This is a radar chart or spider chart, okay? With the 5 non-functional requirements that you choose with your team or the board choose with you and blah, blah, blah. What's the problem? Okay, the problem is that usually these non-functional requirements may be in conflict one another. Okay, if you want good performances, probably you can have other stuff. If you want other stuff, you can't have other stuff and so on. Engineering is the art of compromises, okay? And we know that. So we need to fill that chart. We need to fill the chart in order to explain with a picture how our software should be. There is this chart is what I call architecture compass chart because it's like a compass. Okay, our software should be like this one. There is no specific rule in filling this chart, but this is an example of how you should not do this. These 2 pictures are exactly the same because we are telling that everything is not important or everything is important. The truth is that in order to let this chart to tell a story that you can explain to your team members, you need to define differences. Okay? Let's take this for example. I can read this chart in this way. In order, okay, the first stuff, performances, portability, maintainability, extensibility, and integrability, our top priorities. Full stop. And then you can tell, okay, but in order to achieve the maximum grade of sustainability and a good amount of integrability, I can sacrifice portability and also performance and maintainability on the second order. This is the story that this chart is telling them. Like I said before, a picture is worth 1,000 words. But this picture is worth 1,000 words, not this one. So this is why you will probably need to iterate a lot in order to get a picture that can communicate, in a nutshell, in 10 seconds, the major objective of your software architecture, the constraint in which you are operating with your team. And now you need to implement them. I'm not talking about actual coding, okay? I don't have the time. It's probably we need a full-time workshop. With implement, what I tell here is to compare options, okay? Microservices in Kotlin, or monolith with PHP, that kind of stuff, okay? High-level architecture, and you need to compare one of them. What I usually suggest people to do is that, okay, you can pull on the table all the options that you want. Also, 20 options, 20 different approaches that you have to be sure that we try to solve this software architecture problem. And then you can try, the blue area is, for example, how that kind of software architecture should address the red one that is our objective. And then you can compare option A with option B with option C, etc., etc. This is not perfect. This is not actually something that you can actually compare. But it's easy in this way to remove all the noise. On 20 options, you will probably, the first thing you need to do is to remove all the ones that you are sure that are not useful for you. Now let's imagine that you have 30 options on the table brought by your technical team, and you are the engineering manager or whatever that you need to decide, the tech lead, whatever. You can try to use this stuff with them to choose the best free one, the first three that you think that are the best solutions. And after that, you need a deeper analysis, okay? I usually use this simple, this is an Excel file that I use. It's quite easy. I put the 5 non-functional requirements on top. I define a fitness function. A fitness function is a way to calculate how my software architecture is arriving to the fit with my objective, okay? So for example, performances. I define that in order to perform performances, I have an end-to-end execution time to run the main user task. Okay, I create a login form. Okay, automate a process. How much time the user needs to make the login form? Simulating the click, simulating the REST API, whatever you want, and so on. And then here you have, now just an example, Kotlin or Elixir, okay? But you may have also more complex options. And then you fill it. The first thing to do is to fill the weight. The weight is the value on the chart. Easy. Okay, this is the easy part. Then you implement some POC, you make some study with the team, and this is why you could do that only with 2 or 3 options, because you need time to do that. And you fill the fit column. And so, for example, the Kotlin Spring for the landing curve fit 2. So you normalize the value to 1 to 5. And you say, OK, we have PHP Laravel. We have the maximum level of learning curve. Is a false friend. The maximum level of learning curve means that you need small time to build it, OK? It's a contrary, OK? So it's an high level means a small learning curve, OK? Don't make it. I explain this because I always make confusion with my team. So after that you made POC, study, whatever you want, you fill, or you let your team fill, the fit columns. And that is just a weight and ranking. the number that you see here is just 5 multiplied by 2 plus 2 multiplied by 4, and so on. And in this way, you have the actual winner of the application. So this is how you arrive from this is a visual one, to a more engineering standard approach of decision making. And that's it. The only thing that I would like to add at the end of this talk is that, of course, nothing is written on stone. Imagine the famous startup in the garage in your neighborhood. Okay, you make a lot of money, you are a scale-up. And the scale-up has a completely different approach on problems instead of the startup. And so probably what you need to do is that every 6 months, if you're a startup, I suggest every quarter. Okay, but if or every 6 months, 1 year, quarter, it's up to you to decide. Repeat the exercise again. Be sure that you are working with the right non-functional requirement for that specific time of your lifespan of your company, and be sure that you are the solution that you are implementing are going in that specific direction. It's just not a one-time design that you need from the start of the project. As you know, for agile methodologies, emergent design is the way to build successful product from an engineering point of view. But the point is to be able to build emergent design, you need to be sure that you're pointing in the right direction. Okay, that your business needs are aligned with your non-functional requirement. That's it. I'm very happy to be here, and if you have any question, I'm here for you.